When we look at the partial fraction decomposition heuristic, we can see that quadratic factors are possible, but we have yet to see any. So don't you think it's time to look at a case of those? Why, yes, it is. All right, I'm going to leave this up here for just a second. Okay, so a couple things. Step 1, the degree of the numerator is 2, which is less than the degree of the denominator, which was 3. So yay, that's done. Step 2, we need to factor that denominator. X cubed minus x squared plus 4x minus 4. Factors with a method called factoring by grouping that you should have learned somewhere in Algebra 2. So you group together the first two terms, so it's x squared, and if I factor an x squared out of those first two terms, I'm left with x minus 1. The next two terms have a 4 in them, so then I factored that 4 out, and that leaves me x minus 1 there. Now you'll notice both these terms have x minus 1 in them. So I can factor x minus 1, x squared plus 4. Now x squared plus 4 is irreducible. In algebra class, they'll sometimes call it prime, right? Because a prime number is an irreducible number. So x squared plus 4, the sum of squares is irreducible, so we're done right there. So that means that step 2 would be to factor that denominator, and then I'm going to kind of write it over here. So x squared over x minus 1, x squared plus 4, quadratic term, is equal to, and I'm going to do two steps at once. So I'm kind of doing 2 and 3. 2 started over here, but I kind of finished writing it over here. And then 3 would be to write it out. So it'll be a over x minus 1, because I have a linear term. Linear terms are a constant over that term right here. Plus, and then I have a quadratic term. So for a quadratic term, you write bx plus c. So that's what I'll write, like that. Take that out of there. All right, so now I will multiply everything by that common denominator, x minus 1, x squared plus 4. Okay, and so that'll get me step 4. Now it's always the denominator of the integrand over here, and that's for a hint. So it'll be x squared equals, in this term, the x minus 1s would cancel, be left with a times x squared plus 4, plus, and then I have bx plus c, all of it, so I put it in parentheses. The x squared plus 4's cancel, and I'm left with x minus 1. Like that. Lovely. All right, there's my base equation. Simple and straightforward. Okay, so we have choices to make. We could substitute numbers in. So you could put in, say, x equals 1. That would make this whole term go away. We could do that, right? And then the problem is finding another term that would make this one go away. And the answer is there isn't one that's a real number. So we could play around with that. Okay. But if you want to, you can say, let's let x equal 1. That'll be 1 equals, this term will go away. It'll be a times 1 squared plus 5, which is, or excuse me, 1 plus squared plus 4, which is 5. So a is equal to 1/5. There, we have a. All right, well, I have a, but I don't really have anything else. So then I have to try to come up with a b and a c. So we could rewrite this a little bit and kind of choose different numbers and play around. That's another option. So you could let's say x equals 0. If you let x equals 0 and you know that a is 1/5, then you can kind of say, well, 0 equals 1/5 times 0 plus 4. See, that's why we chose 0. 0 plus 4, which is 4. Plus, and then 0 would make the b term go away. So all that's going to be left with is the c term times -1, right? Because 0 take away 1 is -1. Okay, so this means that -4/5, because I bring that to the other side, equals -c. So that means that C is positive 4/5. Hooray. All right. So I know that 1/5 and 4/5 are my A and my C. And then I just have to pick another number, something else that I think will work out nicely. So 1 is gone and 0 is gone. I mean, those are my go-tos for kind of a simple number. So you could choose 2. 2 might be nice because it would make this term turn into 1. So yeah, I think that's what we'll do. We'll do 2. So my other option would have been -1, but let's let x equal 2. Now keeping in mind, A is 1/5, we know that, and C is 4/5. Oh, I should have kept that pink. Sorry about that. Right? We know those pieces, so we're going to use all of them. Okay, so over here, 2 squared, which is 4, equals 1/5. 2 squared plus 4 is 4 plus 4, which is 8. Plus, and then I'm going to have B times 2 plus C, which is 4/5. And then that's just going to be 1. So times 1. That's why we chose that number, because it makes something turn out nicely. All right, so 4 equals 8/5 plus 2b plus 4/5. So putting these two together, they make 12/5. 4 equals 12/5 plus 2b. Subtract the 12/5 to the other side. So this is 20/5. Take away 4/5. Matter of fact, I'll rewrite it that way, just so you guys can see it. This is 20/5. When I take away 12/5, that'll be 8/5 equals 2b. To get rid of the 2, you multiply both sides by a half, and that'll get you positive 4/5. All right, so I have all my values. Wonderful. Now it's time to rewrite my integral. So all of this work was step 5. Step 6, I'm going to rewrite the integral. I'm going to give myself some space here. Okay, the integral of x squared over x minus 1 x squared plus 4 dx is equal to the integral of 1/5 over x minus 1 dx. I'm just going to separate this one because I can feel that I'm going to have to do a little bit more work here. And then plus the integral of 4/5 x plus, it's 4/5 x plus 4/5. So 4/5 right? There's B, there's C, all over x squared plus 4 dx. Now, let's break this up, and let's also bring the constant terms out in front, because that just makes sense. So this is 1/5 integral of 1 over x minus 1 dx. I know I could do that one pretty easily. Plus, then this is 4/5 an integral of x over x squared plus 4 dx plus another 4/5 integral of, there's nothing left out here, so it's just 1 over x squared plus 4 dx. Now, the first one is easy, right? This is 1/5 natural log absolute value x minus 1. You're done. Easy peasy. This one in the middle requires a U-substitution. U is x squared plus 4. Du is 2 dx. So actually, let me give myself a little bit more space here to do this work here. So this one will be 1/5 natural log absolute value x minus 1. This one will be, well, let's see, I don't really want 2x. I want a half du, which is x. Oops, and I forgot my dx. All right, so then what I'm really taking is 4/5 times a half integral of 1 over u du. All right, so I'll do that in another step. And then plus, and then this one, you might think, oh no, we don't have a U substitution for that one. That's correct. You do not have a U substitution because you're missing an X term in the numerator. However, that one is one that we know very well. It's right here, right? U squared plus A is the same thing as A squared plus U because addition is commutative. It's the arctangent one. A squared is 4. So that means that A is 2, and we're using, it's rule number 19. Now I keep referring to the quick sheet. That's because later this chapter we're going to get the long sheet, the one that's not so quick. So we'll get there in another section. All right, so then this one is actually also easy. This is just going to be 4/5, and then it's going to be arctangent. Oh, du. Rats, I forgot. So we need, if we look at it, it has du in it right here. So we're going to do 1 over a right there. Right, so it's 1 over a. So times 1 over a half, and then arctangent of x over 2, right? X over a. Like that. Right, so that one's number 19. Oh, and then I'll add my plus c. I'll just throw it in now. I haven't technically done my last integral, but I'm about to. All right, so this one would get us the natural log of the absolute value of u, right, when we take the integral. So then all I'm going to do is back substitute in, right? So if I know it's the natural log of the absolute value of u, then I can kind of make that work. So my final answer would be 1/5 natural log absolute value of x minus 1 plus, okay, the 2 goes into 4, so 2/5 natural log absolute value, and then u, which was x squared plus 4. So technically I don't need the absolute value because x squared plus 4 is always positive, but it's fine. Plus 2 goes into 4, 2, so it'll be 2/5 arctangent on that last one. Oop, arctangent of x over 2. And there we have it. None of the integrals was particularly hard, but we did have to separate and do each one separately. So this one's very easy. That's a natural log. This one required a U substitution, and we're kind of tucking it in there. And then this one is actually a formula on the sheet, but you have to know what A is and then apply the formula correctly.